Hello and welcome back to the channel. Today we're going to continue our Arduino for Beginners series and have a look at the Arduino IDE software. Okay, so the first thing we want to do here is navigate to the Arduino website that I'll leave a link for in the description and go ahead and download the IDE software. Please do go ahead and contribute as well, just a small financial contribution to Arduino. They are open source after all. I haven't this time, but I have in the past. I'm not going to dwell on the download process, as I'm sure you all know how to download a piece of software, but once we have that installed, we can move on. Okay, once you have the Arduino IDE software installed, go ahead and open it up and you'll be met with a screen that looks like this. Now, just a little side note on this video. Obviously I'm just capturing my screen here and I'm having some problems with my mouse today. If I take my finger off my laptop trackpad, you can see my mouse just wanders across to the left hand side of the screen, which is very annoying. But that's going to be my job for the rest of the day after this video, is fixing that. So apologies if that gets distracting or hampers the recording of the video in any way. However, now we're in the Arduino IDE software, go ahead and plug your Raspberry, not Raspberry Pi, go ahead and plug your Arduino Uno into your computer via the USB cable that it came with. And it might just take a second to recognize that it's there and maybe install some drivers, but that should all happen automatically. Once we've done that, the first thing that you want to do here is go to Tools and come down to Board. Now, it's already detected that we've got an Arduino Uno plugged in, but it doesn't always do this. So, for example, if we're using our Uno board or our Arduino Mega that we showed in the last video, we'd change what board we have in here. The next thing we want to do is select the port. So here we can see that it has already detected that it's on COM port 3, but it hasn't selected that, so we need to go ahead and select COM port 3. And you'll see down here in the bottom right hand corner you do get Arduino Uno on COM port 3, so you know if you've got a few things going on, you know you're connected to the right device. Okay, the next thing we can have a quick look at is if we head up here to File and Examples. You can see in here there is lots of example sketches that have already been provided for you. So you can go ahead and have a look through these, and we have things like making that LED on pin 13 blink, which we could go ahead and load. However, we are going to just write that ourselves. The examples are really good starting place. So we can have a quick look at the so here's a digital read signal here, and we'll just have a quick look at that blink. So if we were to press the upload button here, this would upload this bit of code here, which would make that LED on pin 13 blink using what we've got here. However, we're going to write this ourselves. So in this area here that's titled void setup, this is where we're going to put things that we need to run once, okay, or things that we need to define for the void loop to run. So it's exactly that. We're setting up what we need the microcontroller to know. The void loop literally runs through the code, so it'll start at the bottom, run down. Start at the top, run down the bottom, then it'll loop back around. Hopefully this will make more sense as we go on. So in our setup, we're going to go pin mode. Oops. Open brackets, and then we're not going to use pin 13 because there's already an LED on that. We're going to make things a little bit harder for ourselves. We're going to say pin 10 apostrophe output. So we've defined pin 10 as an output. The next thing we're going to do is come down to our loop, and we're going to type in digital write, all one word, with a capital W on write. So digital write pin 10, comma, high. So we're basically saying that pin 10 that we've already defined as an output, we want to write that high. High, so digital write high would be, in this case, 5 volts, low would be 0 volts. So this is going to turn our LED on. Now if we just flash this now to a microcontroller, what would happen is we'd plug it in and it would just turn that LED on pin 10 on. But we want it to flash. So we're going to come down to the next line and type in delay. And 1000, I believe it's milliseconds. So a delay is a really good tool. So we've said we're going to set the pin high. Then the script's going to pause for 1000 milliseconds and then do the next thing. And in this case, we're going to go digital write pin 10, and this time we're going to say low. And then we'll come down again and put another delay of 1000 milliseconds in there. So now what's going to happen is the void loop will start. It'll write pin 10 as high, so 5 volts. It'll wait 1000 milliseconds. Then it'll write the pin as low, wait 1000 milliseconds, and then loop back around to the top, high, then low, and so on. And that should result in our LED flashing. So let's go ahead and flash this code to our microcontroller. We'll attach an LED up and we'll make sure that that works. So the first thing you want to do is this little tick here, click it, and this will, well, want you to save it first, that's fine. But this will go through and compile the sketch and it will try and spot any errors that you might have. So we'll give that a second, do its thing. And we can see that it's done compiling, and it'll tell you at the bottom here how much of the available storage on your device you're using. This is actually quite good, and it will spot mistakes for you. So for example, if we take out that semicolon that I put next to this delay and try and compile it again, it will come up with an error saying that it's missing something. This semicolon here is just a way of saying, you know, you've finished writing that line, move on to the next. So we'll add that back in and compile the sketch again. And this time it's coming back with no errors. So as long as we've got a device set and the right COM port, we can go ahead and click the upload button, and it will go ahead and upload the sketch, and the receive and transmit lights will flash away on the Arduino. So let's go ahead and plug all of this in and see if it's working. Okay, so here we have our Arduino. So what I have here is this red wire here is on pin 10, going to the longer lead on the LED, and this black wire here we've got into ground and a 10k ohm resistor. And as you can see, our LED is flashing away with that 1000 millisecond gap in between turning on and turning off. On the Arduino itself here, that little LED that's lit up there, that orange one, that's that LED that's on pin 13. I think that must be just set to high by default. But you could, you know, if you wanted to turn that off, you could do that in the void setup. Just set that pin 13 as low. This other LED here is the power. These two LEDs here, these are the transmit and receive LEDs. Now, these can be really handy to know if you're communicating between your computer and your microcontroller. So what I'm going to do is I'm just going to offshot here. I'm just going to flash this a sketch back to the microcontroller, and we can see these lights flashing here. It's quite a small sketch, so it won't be for very long, but it can just be quite a handy troubleshooting thing to know about. So go and I'll click upload, and we can see them flashing away just for a moment there. Just a really handy thing to know about. Okay, so now we've got all of that working. we'll just have a quick look at some other things that we can do here. So we've called this pin pin 10. Now that's all fair and well when you've only got one thing going on. However, if you're using say an Arduino Mega and you've got many devices attached to it, remembering what device is attached to what pin could get quite difficult. So we can rename these pins, we can define names for them, and then we can refer to them by those names throughout our sketch. To do that, we're just going to, above the void setup, we're going to type in const int. So this is saying that this is a constant value, this isn't going to change. And we're going to name our constant value, we'll just call it green LED. And that green LED equals pin 10. So now we're telling our sketch that pin 10 is called green LED. So in our sketch, rather than saying pin 10, we call it green underscore LED. And when you get more used to using this software and your code is very long, it's much easier to type in green LED or something that makes sense to your project rather than having to remember which pin you've put certain devices on. So we'll go ahead and verify that again, compile the sketch, and you can see that that's come back as fine, and we'll go ahead and upload it and make sure that everything's still working. Okay, and here we are again, this time with our code changed for the LED to be defined as green LED rather than pin 10. And as you can see, things are working absolutely fine. Okay, so I think I'm going to call an end to that video there. I hope that's been useful for someone, and I will be coming with more of this series in the next few days and weeks. If you have found it useful or you'd like to see more videos like this, please remember to subscribe to the channel and like and comment.